All right, so let's do this lim soup lim inf problem. Let f sub n be a sequence of measurable functions on E such that f sub n is smaller than or equal to g for all n where g is integrable over E. Prove that the limit as unity of the soup is less than or equal to the integral of the lim soup. So we can see that here we can use Fatou's theorem, right? So g minus f sub n is a non-negative sequence of measurable functions. By Fatou's, we have that, and Fatou's is kind of just a reverse version of this, so the soup's replaced with imps. So we have the lim inf of g minus f sub n, the m is smaller than or equal to the lim inf of g minus f sub n. And here what's going to be key is this kind of lemma or result that inf of negative a sub n is equal to the soup negative soup, or a sub, we'll keep it a sub. You can think of this as like, okay, so if I have something this is a sub n, right? And this is negative a sub n. The inf of negative a sub n is equal to, corresponds to kind of the soup, but flipped. So the negative soup of a sub n. Okay, so this is going to be equivalent to, well, you see g is not a sequence of functions, so when we take the lim inf of g, that's just going to still be g. This is g minus, but the lim inf of negative f sub n from here is going to be the negative lim soup of f sub n. Same here, so we can split this integral. So this is just going to be g dm minus n dm. This is finite, so we don't have to worry about it being infinite. And then when we take the inf of this, the lim inf, this is going to still remain the same because it's not like a sequence of functions or anything. And this is going to turn into the lim negative soup. So let me just write that out. So this is going to be g dm minus soup. And now we can see that our result basically immediately follows. So when we distribute this, this is equal to g dm minus lim soup sub n dm. We can see that this is less than or equal to this. We can cancel these out, and then when we flip this, we get our results. And we're done.